Okay, so we just had rules for powers of a product. What happens if we have powers of a quotient? So we have two rules here. We can memorize them, but you know what? Let's take a moment and think about where they came from. This way, in case we forget it, we won't run into too much trouble. So, for example, suppose I have this first rule, a over b to the n. We have some rules. We're assuming that these are not zero. Obviously, we would not want b to be zero here because one thing we're never allowed to do in this class is divide by zero. And we're also going to insist that n is an integer. So what does this mean? Well, this means this is equal to a over b times a over b times a over b over and over again. How many times? Well, n times. Well, okay. What does this mean? Well, we know how to multiply fractions, hopefully. We multiply the tops and we multiply the bottoms. So what do we have here? We have a bunch of a's in the top and a bunch of b's in the top. How many a's are we going to end up with? Well, we had a over b n times, so we're going to have a total of n a's. Well, I'll just say n right there. And how many b's do we have? N b's. Okay. Well, what does that give us? A to the n over b to the n, which is exactly what our rule tells us this should be. Now, of course, what happens if this is negative? Well, let's look at this rule here. Well, we would just flip the entire thing first. That would give us b over a to the n, and we get the same thing over here on the right. Once again, we're assuming that b is not zero. Otherwise, we would end up in some trouble here because one thing we're never allowing ourselves to do is divide by zero. Okay, so this is actually a pseudo-proof. I haven't gone over all the details, like, for example, what happens if n is negative here or n is negative here, but then we just have a negative and a negative, and that would be a positive, and we'd be back in this case. But it's sort of a proof. It's an argument for why this is true. So let's pretend that we forget everything that we just saw right here. We've forgotten it all. And we have some problem with an a over b to an n. So let's say we have 2x over 5 cubed. Okay. Well, remember, anything cubed is that thing times itself times itself. So if we do forget the rule, what happens? Well, we end up with 3 2's in the top times 3 x's over 3 5's. So I have 2 cubed times x cubed over 5 cubed, which is 8x cubed over 125. We can also use the rule, but this is what we would get if we forgot the rule. And you'll see that if we use the rule, and then use the power of the product rule, we get the same result. So it's good to remember the rule because in this case the rule was faster, but if we forget the rule, we could even generate the rule if we understand where it comes from. So next, let's look at a few more examples of quotients to powers in the next video.